Hi everyone. Let us discuss with an example. Case 1, series connection. If you connect 3 solar panels in series, each having the same rating of 50 watts, 12 volts, the output voltage becomes 36 volts. The total wattage becomes 150. The current is 4.16 amperes. When you calculate the current for an individual panel or for an overall circuit, the current remains the same due to a series connection. In simple terms, voltage ratings are additive, but current remains the same in series circuits. Usually, series conduction is employed to increase the voltage ratings. Case 2, parallel connection. If you connect 3 solar panels in parallel, each having the same rating of 50 watts 12 volts, the output voltage becomes 12 volts. The total wattage becomes 150. The current is 12.5 amperes. When you calculate the voltage for an individual panel or for an overall circuit, the voltage remains the same due to parallel connection. In simple terms, current ratings are additive, but voltage remains the same in parallel circuits. Usually, parallel connection is employed to increase the current ratings. Can we connect different voltages or wattages in series or in parallel? Yes, you can connect solar panels in series and parallel with different voltage or wattage ratings and it will work. But it is not recommended because you may experience some power loss. Let us see how. Case 1. Let us assume two 12-volt 100-watt solar panels are connected in series. Total voltage is 24 volts, power is 200 watts and current is 8.33 amps. Now let us connect two solar panels with different ratings. Let solar panel 1 have a 12-volt 100-watt and solar panel 2 have a 12-volt 50 watts connected in series. Actually, the total voltage is 24 volts. The wattage is 150 wattage. The total current becomes 12.5 amps. This 12.5 amps is got by adding the current from panel 1, 8.33 amps, and panel 2, 4.16 amps. Since this is a series circuit, there can't be two different currents, so the circuit will adopt the lower value, which is 4.16 amps. Finally, the voltage is 24 volts, the current is 4.16 amperes. So, the total power becomes 100 watts by multiplying the voltage and current values by 24 and 4.16 respectively. Instead of 150 watts, we get only 100 watts, which means we lost 50 watts. Case 2. Let us discuss what happens when these two panels are connected in parallel. Here, the output voltage will be 12 volts, the current rating will be 12.5 amps. By adding the individual current values of 8.33 amps and 4.33 amps from panels 1 and 2 respectively, since the current ratings are additive in parallel circuits, we get an output power of 150 watts by multiplying the voltage and current values by 12 and 12.5 amperes respectively. Let us discuss different voltage values. Case 1. Let us assume two solar panels having the same wattage but different voltage levels are connected in series. Let the solar panel 1 have 12 voltage, 100 watts, and the other panel be 24 voltage, 100 watts. Since it is a series circuit, the voltage values are additive, so the value is 36. But the circuit will adopt the lower current value from panel 2 as 4.16 amps. So, when we multiply the output voltage of 36 volts with 4.16 amps, we get total power of 150 watts. From a total of 200 watts, we get only 150 watts. There is a loss of 50 watts. Case 2. Let us connect the two panels in parallel. Solar panel 1 has 12 voltage and 100 watts and panel 2 has 24 voltage and 100 watts. In parallel, we know the voltage remains the same throughout the circuit, but here are two different voltage levels of solar are connected in parallel, then the circuit will adopt the lower voltage rating of solar panel 1, that is 12 volts. So, the output voltage will be 12 volts and the current rating will be 12.5 amps, which we got by adding two individual current ratings of each panel 1 and 2, 8.33 and 4.16 respectively, since in a parallel circuit, the current is additive. By multiplying the output voltage and total current by 12 and 12.5 respectively, we get 150 watts as an output. From the connected 200 watts, we are using only 150 watts. 50 watts as loss. Case 3. Suppose we have 3 solar panels, each with a different voltage and current rating. Let panel A be 12 volts and 2 amps, panel B be 18 volts and 3 amps, and panel C be 24 volts and 4 amps. The power of panels A, B and C is 24 watts, 54 watts and 96 watts respectively, and the total power is 174 watts. Let's look at what happens when these 3 panels are connected in series. As we discussed previously, the voltage is additive and it becomes 54 volts. The current rating becomes 2 amps since the circuit will take the lowest current value. So the power of the entire solar circuit becomes 108 watts instead of 174 watts. We lose 66 watts. If the 3 panels are connected in parallel, the current values are additive and it becomes 9 amps. Then the circuit will take the lowest voltage value of 12. So the total power becomes 108 watts instead of 174 watts. Here, we also lost 66 watts as a loss in power. Case 4. If the load is 200 watts at 24 volts, you can connect 2 solar panels, each 100 watts at 12 volts in series, or 2 solar panels, each 100 watt 24 volt in parallel, or a single panel consists of 200 watt 24 volt. If the load is 200 watts at 48 volts, you can connect 2 solar panels in series, each 100 watts at 24 volts, or 4 solar panels in parallel A, B, C, D. Let A and B have a 50 watt 12 volts connect in series, and C and D have a 50 watt 12 volts connect in parallel. A and B will give you 100 watts at 24 volts. Likewise, C and D will give you another 100 watt 24 volts. When these two sets are connected in parallel, you will get the desired output as 200 watt and 24 volts. Power ratings are additive both in series and parallel circuits, but voltage and current are additive in series and parallel circuits, respectively. Let us discuss how to design the solar panel circuit for the given load. Let's assume the load has 400 watts and the operating voltage is 24. Assume you have 4 solar panels, each of which has 100 watts and 12 volts as its output or operating voltage. Name the solar panels A, B, C and D. To get the required output, connect the solar panels A, B in series and C, D in series. Now the output of both series connections will produce 24 volts individually. Connect both the circuits in parallel so that the voltage remains 24 volt, which match the load, and total wattage also become 400 watts. Now you can connect with load via battery or charger controller. Ensure the operating voltage of the solar panel, battery and load are equal. In case the load has 400 watts and the operating voltage is 48, just connect all the 4 solar panels A, B, C and D in series. Thank you for watching. Have a good day.